Okay. Now 13.8, now let's do some actual problems. Find the relative extrema of the function f of xy equals negative x cubed plus 4xy minus 2y squared plus 1. So I need at least both the partial derivatives to be equal to 0 in order to even have potential relative extrema. So let's take the partial derivatives. The x partial derivative is negative 3x squared plus 4y. The y partial derivative is 4x minus 4y. So when does this happen? We've got the equation negative 3x squared plus 4y equals 0. And here we've got 4x minus 4y equals 0. Okay, so this is a system of equations now. I can get this equation more easily to solve for substitution here. You get y equals x. That's when that happens, and I can substitute that in. So negative 3x squared plus 4 times x equals 0. If I factor out an x, that'd be x times negative 3x plus 4 equals 0. So either x equals 0 or x equals, it looks like 4/3. Okay, so what does that mean? When x is 0, what is y? Well, we know y equals x. So that means we have the point 0, 0, whatever z is. When y is 0, or when x is 4/3, again, we know x is the same as y, because y equals x. 4/3, 4/3, and whatever the z value is. We need to plug it in to find out if it's an actual max or min, so we can go ahead and plug in those numbers now. When I plug in 0 to everything, this would be 0, 0, 0 plus 1, so it looks like 0, 0, 1. When I plug in 4/3, we would have negative 4/3 cubed plus 4 times 4/3 times 4/3 minus 2 times 4/3 squared plus 1. So a little ugly. So that would be negative 64/27 plus 64/9 minus 32/9 plus 1. These have a common denominator of 9, so that's negative 64/27 plus 32/9 plus 1. I can get a common denominator here. Negative 64/27 plus 96/27 plus 27/27. This would be 32/27. Looks like it should be 59/27. Okay, so we have 4/3, 4/3, and then 59/27. Now, these are our two potential, these are critical values. So what do I use to find the answers based on our critical values? That d, which is the partial derivative f(x)(x) times f(xy) minus f(xy) squared. So I need the second partial derivatives at those points. So what is my second partial derivative here? Second partial derivative with respect to x is negative 6x. Second partial derivative with respect to y is negative 4. What about my partial derivative once in each direction? So I can either take my partial derivative with respect to x and do it again with terms of y, or do y's in terms of x. Either way, you should get 4. So in this case, negative 6x times negative 4 would be 24x minus 4 squared, 24x minus 16. Now I have to analyze this at each point for x and y. In this case, x is the only thing that matters. So when I plug in 0, so 0, 0, 1, I get 24 times 0 minus 16, which is negative 16. We said if it's less than 0, this is automatically a saddle point, which means it's neither a max nor min. However, when I plug in 4/3, I get 24 times 4/3 minus 16. This is actually 32 minus 16, which is positive 16. Now what does it say? That means our d is positive, and our fxx is what? I have to plug it in here, so d is greater than 0. My fxx at that point, second partial derivative with respect to x, is negative 6 times 4/3, which is negative 8, which is negative. So what happens when our partial derivative for x is negative and our d equation is positive? It says if both are positive, you have a minimum, but if d is positive and the second partial derivative with respect to x is negative, you have a maximum. So these two together mean we have a relative max at 0. It's the other point. 4/3, 4/3, 59/27. Since the other one was a saddle point, it's neither a max nor a min, so this is the only critical point for which this is a maximum or minimum. And we'll do another one in the next video.